Welcome to building your own widget with the JavaScript API. My name is Matt Driscoll. I'm on the JavaScript API team. I'm here with my colleague, JC Franco. We both work on widgets and JavaScript stuff in the API. So this session, we're just going to show you guys how you can build your own widget using our new widget framework. And so that's what we'll start out. We'll start out with talking about what widgets are and what you kind of need to know to be able to make them. Then we're going to go through the widget framework and how it's kind of composed and set up. And after that, we'll cover a little bit about how you guys can use some out-of-the-box themes and then create your own themes using Sass. And then we'll go through piecing together a widget from scratch and show you, and all this code will be available on GitHub, which we'll share the link at the end of the session. And then we'll cover some tips and tricks for how to build a widget, things that'll save you guys time or help you guys out. So about widgets. They're basically encapsulated pieces of user interface and code. They're like one single functionality or UI piece, cohesive. And so why would you create one of these? Well, you do it if you're going to reuse this UI piece multiple times throughout your application, or maybe you want to share it throughout different applications, something like that, and just have it packaged in a nice, neat container, and much easier to modify, change, stuff like that. And how you can do that is you can use our widget framework to build widgets for whatever framework you guys are using. So some of the prerequisites for building widgets with our framework, you're going to need to know a little bit about our Accessor class, which is a core component of our API and allows you to kind of set properties, get properties, and things like that. And then our new widget framework uses TypeScript, which is just a superset of JavaScript. So you're going to need to know that to be able to create widgets using our framework. I'm going to turn it over to JC now, and he's going to cover all about Accessor.
Thanks, Matt. So as Matt mentioned earlier, the Accessor is the backbone for the JavaScript API. All the API classes extend from Accessor, and the main objective of Accessor is to help improve the developer experience by setting the foundation and consolidating a set of patterns that are used across the API. This is because a lot of thought went into Accessor, and with the goal of overcoming a lot of the pain points that came from using the 3x API. I'll go through some examples later on. And another neat thing is that it supports TypeScript development. So I mentioned that improved developer experience, and one of the examples is any Accessor-based class can be instantiated and initialized by passing one object, this is the unified object constructor pattern, and what it means is whenever you create your instance or your class, whenever you create your class, you pass along this object, and whatever values, whatever properties are passed in this object will get set into your instance. So you see that across multiple types of classes across the API. Accessor also allows you to define properties and also the way they behave. I'll show how to do this a little bit later with TypeScript. Another really neat feature is that it allows you to watch for properties. So if you are used to developing in 3x, a lot of the ways, typically you would react to property changes by listening to an event, and then whenever that event got emitted, you would call some other piece of code. So events in 4X we're relying less on those, and the way we are promoting the proper way to do it now is to watch for properties, because any property from a Accessor based class can be watched, which means you can provide a callback if you're watching for a specific property, and whenever it changes, it'll get executed. Similar to the event emitting pattern. You can also provide a string of nested properties, and Accessor will go deep down to the chain, and whenever that last property is updated or part of the chain is updated, you'll get notified. You can also watch for more than one property if you're interested. So you just pass along 2 properties and it'll the appropriate callback. So I'll switch gears and talk about TypeScript a little bit, and it'll tie into the Accessor, because I'll show how we use TypeScript in Accessor for our widget development. So TypeScript is a programming language. It has an optional typing system that gives you type safety. I'll show an example of that in the next slide. It goes through a compilation step, so that means that our TypeScript code goes through the compiler, and then it'll generate JavaScript. So this process of the TypeScript being processed by a compiler allows it to check for errors potentially and let you know up front, and be able to let you respond and fix these errors earlier in the development cycle. You can also leverage ES6 syntax and make sure that the JavaScript that you compile targets ES5 browsers or ES3 browsers as well. So ES6 syntax is pretty nice because it allows you to write in a more concise and expressive way. So you could use the future now and still compile to normal JavaScript. So this is one example of how type safety may help prevent errors. Say you have a property of type, a view property of type map view or scene view. If later on for some reason you ended up assigning a string to it, you would immediately get a compile time error about the types not being compatible. So, and even some of the modern IDEs will run the compiling step behind the scenes and let you know as you are typing that your code might be incorrect. So typings are basically how TypeScript can know what things really are. So the better you type the properties or in your classes and methods as well, the better TypeScript will be at pointing out these issues. Now typings are optional, but it's really nice to have if you have the time. It's in this little snippet, I'm defining a type of presenter name with a few predetermined values, and I have interface of person with a name and an age. Extending that, I define a presenter interface where the name is now of type presenter name. So if later on I try to assign a person to a presenter variable where the presenter name doesn't match, I'll get an error. So that's an example of how TypeScript can keep your code safe. So I talked a little bit about ES6 syntax, and I'll show a few things that you can leverage by using TypeScript. So some of these are fat arrow functions, and it's a really nice way of creating anonymous functions and binding them to the current context. Template strings are really neat too, because it allows you within one single template to define a string. It supports multi-line, and you can also reference local variables if needed. Destructuring can be really useful as well. So within one single line or one assignment, you can set the values of multiple variables and even define default values if any of these properties are undefined. Rest parameters can be useful if you have a method that accepts more, if it has additional parameters, it makes it easier to capture all those additional parameters within one variable by using the rest parameter syntax. Decorators, I'll get into more detail in future slides, but they essentially allow us to enhance classes, methods, properties, as well as arguments within our code. So this little snippet, let's say we have a logging decorator defined somewhere, and I have a property and I assign it a string foo. By using the decorator, the log decorator, I can make it so that just by adding this, applying this decorator to the property, anytime the property is modified, I can log to the console the value. So you have a lot of flexibility by creating these little decorators that can help you with your future development. So the support for for TypeScript in IDEs has grown. So it makes it much more easier to get started with TypeScript within your current environment. Personally, I use WebStorm and Matt uses Visual Studio Code. Talking at a high level, the way you would get your environment set up with the JavaScript API and TypeScript is a matter of installing TypeScript, installing our JavaScript typings, and then just start writing code. We have our SDK has a really nice page instructing you how to get that set up. I recommend you checking it out. So let's go back to the decorators and see how we can use them how we use them in widget development. So if you want to create a class, this is how you create a class with 4x JavaScript API with a subclass decorator and the declared helper. This sets up the internal wiring for our classes. If you have a class that extends multiple classes, you want to use this pattern where to preserve the typings, where you need to define an interface that matches the name of your class, and which extends the class bases that you are including in your class. If you want to define a property, it's just a matter of using the property decorator on top of such said property. But there are multiple ways of defining your properties and how they behave, and I'll show how you can do this. So if you have a custom setter, it'll still get used if you use the property decorator. So this will still, in the context of Accessor, you'll still get the same API, be able to use the same APIs, and this is how you define a custom setter. So inside, if you had some sort of additional logic that you wanted to run, in this example, I can kind of validate that the value that's being passed along is correct. And the way to actually set it is by using an internal set property. If you had a custom getter, you would do pretty much the same thing. You have access to an internal getter as well. You can define computed properties where you define the dependencies of your properties. Say you have a property full name, and this full name depends on other additional properties on your class, first name and last name. So this is, full name is computed from those two properties. And the really neat thing is if during runtime, if your first name or last name changes, this property will get recomputed automatically. So say you're watching for full name. If I change first name, the watcher will get called appropriately. You can also mark properties as read-only. And if you try to assign a property to if you try to assign a value to one of these properties marked as read-only, you'll get an error. So within your class, if you want to update a read-only property, you could do it via the internal set method, which I showed previously. Or if it's a computed property, you can mark it as read-only and it'll use the same wiring as before. A really neat feature that you can use with a property decorator is type, which allows you to autocast. And if you're not familiar with autocasting, the concept is if I define a property to be of type my class in this instance, if I pass an object with values, internally that property will get initialized with that class using that object that I instantiated. So it makes for it helps you produce cleaner code because you no longer have to require my class in your class and instantiate it yourself. You can just pass along an object if it supports autocasting, and it'll take care of it for you. You can also alias a property. So if I had a bar object in my instance that had a baz property, whenever I access foo, it'll actually return whatever baz is. There's a shorthand version of aliasing, which we use a lot in when developing widgets. And we'll see more of this when we go through the widget code. So accessible handler is another decorator we have to help us reuse a callback that is meant to be used as a click handler or a key handler. For example, if you want to react for when the user presses on a button, if it's not a native button and you want it to reuse the same function for the click handler and the key handler, this is a really useful decorator.
It's on the enter key, and then tabs will trigger this basically. It's like an accessible button click. So you don't have to use just the mouse, you can use keyboard, space, and enter.
Space and enter, yeah, thanks for that. One key decorator that we use in widgets is the renderable, which is used in conjunction with property, and what it does is it wires up the widget property so that whenever it changes, it'll trigger the rendering. So typically you will mark any property that is closely tied to a UI as renderable. So whenever that property changes, the rendering will get triggered and it'll automatically update the UI. And you can also specify nested properties. So if I had a view model which has some properties that I depend on, if any of these nested properties change, my UI will render. You can find more details about the Accessor and the way we use decorators for widget development, as well as some other patterns that you can use in the SDK. And I'll hand it back to Matt to talk a little bit more about the widget framework.
Thanks, JC. So I want to go through kind of some of the parts of our widgets. And the first one is JSX, which is, I'll explain a little bit later, but it's a nice way to write HTML in basically JavaScript. And it was kind of pioneered by React by Facebook. And then I'll go through some of the life cycle of our widgets, cover some things about properties, some, I guess, best practices for methods, and then how you can use events in our widgets too. So this is our new widget framework, Esri widget. Like I mentioned before, it's Accessor based and built with TypeScript. So this is what you would use to basically create a widget yourself using our framework. Here's an example of JSX. As you can see, it looks pretty much just like HTML, except for instead of quotes, I have these brackets, which will tie to properties or data or functions, stuff like that. So in this simple example, I'm assigning a class based on a property. I'm assigning a function on the onClick and a tab index tied to a number 0 so that it'll be focusable and accessible. And it's just a div that has text saying hello world. So I can write this in JavaScript. For example, in our render function, JSX needs to be returned to render some kind of user interface. So this is like a sample of what you would be writing. It basically adds XML syntax to JavaScript, looks very similar to HTML. And the nice thing about it is we can use JavaScript inline in our JavaScript. Or use HTML-like in our JavaScript. So this is kind of the life cycle of our framework. You have the constructor method, which you can hook into and define yourself. We have a post initialize, which you may want to use to set up event handlers, things like that, after the widget's been constructed or instantiated. You have the render function or method, which is our main method to return a user interface and define that for your widget. This is probably where you'll be doing most of your work in the view. And then lastly, a destroy method, which you can use to do things like clean up event handlers, destroy other widgets that you may have created, any other kind of cleanup of, removing variables, stuff like that, properties. So this would be like the constructor, and this constructor I'm accepting parameters, which would be like an object or something like that. It's a superset of the constructor widget, so I don't want to override it, but I want to add on to it basically. And I would just do my own JavaScript code here. Here's a pretty common look of post initialize, where I would wait till the widget to be set up, and then I want to create an event handler that the widget owns, watching some property, and whenever that property changes, I want to call a function that in this example is called property changed. So I can do things with that.
Well, one key thing about post initialize is that it'll get called before the widget actually gets rendered. So if you have some setup that you want to do before and not have it affect the UI, would be a good point to do it as well.
Good point. Mentioned render already. This one, return JSX. So if you had a really simple widget that just like a button or something like that, this is kind of what it would look like. You would return JSX in the form of a button element with housing a title property on your widget, something like that.
This is TypeScript?
Yes, yes, JSX in TypeScript. And then here's our SDK kind of going through widget rendering. You can find this page if you go to our API 4.3 under the guide section, widget development. And this is what you'll need to get basically set up with creating widgets. And there's some parts about JSX and kind of how it works. It goes through the life cycle that I'm going through here. Our decorators, which Franco mentioned a little bit earlier. Some simple samples on how you'd actually, there's a really simple, basic widget right here. Properties, how to extend widgets. So this is where you're basically going to go as a resource. And there's some good samples down here for like the render function, adding styles. When you'd use something like after create and after update, binds, and then keys, which we'll talk a little bit about as we're building our widget. And lastly, the destroy method in the lifecycle. Like I mentioned before, you might want to clean up listeners, destroy other widgets, dereference some variables, things like that. Basically cleaning up so that there's no, memory problems, stuff like that, or destroying other things. This is an example of getting and setting properties. Like it's based off of Accessor, so if you've used other classes in our API, you should be pretty familiar. For example, if I want to get a property called property on my widget, it would just be referencing like this. Setting a property would just be setting the equal to whatever value I want to set it to. And then we mentioned a little bit earlier our internal setters that will not trigger the setter. So if you don't want to trigger any watchable event listeners, things like that, this is what you would use to set something internally. And we also have one for get too. So now I want to talk a little bit about view models. View models are the brain of our widgets. And we have our widgets separated into view models and views to kind of make them distinguished, and so that you're not like confusing two different things. So the core of the logic resides in the view model. This is like the brain. It handles data, provides an API for widgets, and doesn't involve any user interface or DOMs, things like that. So like I mentioned a little bit, we want to do this to keep things separated. Concerns are in different areas. We can reuse a view model and create two different widgets that look completely different. And it makes it a lot easier to edit code and stuff like that. Next we have the views. And this is the presentation of the widgets. So a view would use a view model to basically create a face or interface of the widget. And this is what we mean by Esri widgets widget. It's what you're extending is basically a view. So it uses view model APIs to render user interface, and things like DOMs and presentation logic is going to be in here. So same thing, separates concerns, and also framework compatibility. So you can take a view model and use it to basically work in your framework of your choice. You know, like maybe you're using jQuery or something like that. You can use one of our view models and recreate the UI in jQuery or Bootstrap or something like that. So here's how you'd define a view model in your widget view. You'd basically add a property decorator, and you'd add the type of it to your view model. And then setting the view model property, you would set that to the type of my view model, and you just instantiate your view model there. Kind of like a method convention for your widgets. Your public methods, it's good to declare it as public so you know what it is later. And private would be for private methods, and using an underscore as a start would just kind of help you organize your code into different sections and stuff like that, and recognize what things are internal and what things you want to expose as an API.
I just want to mention that public is the default namespace for the method. So if you declare a method and there's no namespace, it'll be public. Next,
events. So views already have the ability to emit an event by default. If you are creating a view model that needs to emit an event, you can import Dojo evented and emit events there. And you can also alias an event with a decorator called VM-event. So here's how you basically emit an event in your widget. You would just call this.emit, whatever your event name is, and then whatever you want to emit in that event. Usually an object with some properties or something like that. So in a view model, you'd want to import the evented library, and you want to extend your view model with that library so that you can call this.emit, whatever your event name is, and whatever you want to be admitted in that event. You can also alias view events. So let's say there's an event on my view model called VM-event, and I also want it to be on my view as well. I can alias it this way so that this will be triggered if someone listens to either the view model or the view.
When we alias properties or events, the main idea behind it is so when you create your widget instance, you can listen for events right on the widget instead of having to go through the view model or access properties as well. So that's kind of the main reason behind aliasing.
Yep, thanks. So now I want to talk a little bit about theming. And our widgets all have out-of-the-box themes from our, that you can find on our SDK. We have a good styling topic, which I'll show in a sec. All our widgets are using Sass for styling and following a BEM convention for naming classes and structuring the Sass. And so if you're not familiar with Sass, you can check it out at sasslang.com. It's a CSS preprocessor, so it basically lets you write CSS easier, and you compile it, and it goes into CSS. And what you gain is variables and functions, things like that. I'll kind of go through that in a second. And then BEM, I'll go through that in a second too, but it's a block element modifier methodology, and it makes CSS a lot cleaner and more distinguishable. So let's check out our SDK styling page. If you go to our API guide topic again, scroll down to styling. This will show you our default style sheet for themes, and then all the different style sheets we have available out of the box that you can use. So we got light, dark, light blue, dark blue, pretty much all RGB standard colors. And then you can also create your own, which I'll go into a little bit. And here's an example of how BEM kind of looks. So I'll go through it on our slide too. We have one here. So out of the box, let me show you how our themes look. So by default, this is our default theme. You see our widgets are like white, our layerless widget, print button, zoom controls, compass widget. But just by switching out the CSS, I can, get a dark theme, light blue, dark blue. So you can kind of use these things to fit whatever your app needs to look like. Or maybe you're using a base map that's darker and you want kind of a darker theme that doesn't contrast so much. This will get you most of the way, pretty much. It's pretty nice to just be able to include a style sheet and have it look to fit your app better. I mentioned Sass a little bit. It's a CSS preprocessor. You get variables, you get mix-ins that can be reused throughout your app. You can, including is how you use the mix-ins. You get import, so you can basically have CSS files split up in a more modular way. And you can extend classes, which will allow you to do inheritance. So it gives you a lot of more power and control, and makes coding actually a lot easier with CSS. So it makes it easier to restyle, theme things, more modular. You're not repeating code. Your code's more organized, and in the end, you basically write less code, and it'll look better. You can also do things like compile Sass in a minified way. So if you want it to be minified for production, things like that, it gives you a lot of control. So Sass has a nice install page. And there's a couple different ways you can do it. You can use applications if you're kind of afraid of the command line, or if you're more inclined to use the command line, you can do that too. It's pretty easy. If you're using like a Mac or something like that, it's just a command line like install thing. And then to compile it, you would just do something like you just call Sass basically. And we'll show you that in a second. And all of our themes that I just mentioned out of the box are available on our JS API resources GitHub page. So if you go to github.com/Esri, and then go to our repository called JS API resources. You can see how to set it up, and it'll explain the structure of our themes, how to work with our themes, some of the default options. You can turn certain widgets off for the theming, stuff like that. It points out the structure. And to use this, you would just, if you want to create like a custom theme, you would just copy one of the existing folders of our themes, and they have is a SAS file with a bunch of variables for color codes, font sizes, things like that. You would basically just copy that, name it your own folder, whatever you want to call your theme, tweak everything, and host it yourself, and you basically have a brand new theme that's custom to whatever you need it to look like. So this is a good guide for that. Kind of shows examples, what you can do. This one, I guess, was created called Skinny Green Latte. Kind of a cool name. And this is a BEM, which I mentioned a little bit earlier, block element modifier. So this is a methodology to basically, it's a way to standardize naming and structure of how you're writing CSS. So you're following, standards and not kind of doing things differently. I don't know if you've worked with like other team members and you guys kind of write code SAS styles differently, and then things are named all inconsistently. This really helps with that, so that everything kind of makes sense and you're all kind of following the same thing. But basically what it is, a block would be, for example, the widget name. So you'd have an example widget name. And let's say in that widget you have an input element and a submit button. So a couple blocks would be example widget __ input and example widget _ submit. And let's say one of those, let's say when you click the submit button, it has a loading spinner or something. Or actually on the widget itself, you need to specify if it's submitting. You can have a modifier on the widget which basically just applies additional styles to it. So that's what this would look like. And here's another one where it's like the submit button, you could say, is disabled. So we use this in our widget framework. It seems to work pretty well. So now we're going to actually piece together a widget. And I'll let JC kind of explain the widget in a little bit. But I guess I can show it off real quick. The widget basically will listen to your voice and then perform commands. So if this works, I can say, listen. Nope, it's not working. It's really picky sometimes. Listen. Zoom in. So yeah, so it does all these kind of commands. I'll let JC kind of show off some of the other ones. I don't want to steal his thunder, but I think I had to mention this first. Okay, so to get this widget set up, first thing I want to do, I have a couple steps. So we can you can kind of go through this yourself if you wanted to later, once we share the URL to the code. But what I want to do is I have my demos here. I have this widget we're calling Yo Esri. We have a starting folder, which is basically the structure without any of the code we need to do to get ready. And what I want to do first is set up the index page to be able to pull in our widget and also put in the styles for our widget using SAS. So the first thing I need to do is set up a Dojo config, and that will allow me to create a package where I'm going to store my widget. So when I require demo Yo Esri, it's going to look in this location and grab that. So I want to do that. I want to do it before I require the API JavaScript. So I set that right there. Next thing I want to do is add a style sheet for my CSS. And I can put that in the head underneath the main CSS or somewhere like that. and I want to require my new widget. So here I just have a basic map set up and a view. What I want to do is set it up so I'm requiring demo yo Esri and passing this in. And then I want to instantiate my widget and put it in the UI. There we go. Okay. So now I have it set up so that I can use the widget once I write it, but I need to actually add CSS to the widget too, so that when it's built, it'll look pretty. That's where these steps come in. Have a file here, empty Sass file right there. First thing I want to do is create some variables, some Sass variables. And I can specify things like I want the icon size to be 24 pixels by 24 pixels. Let's say I want the button size to be 40 pixels with a radius of 20. I want the fill icon to be white. And when I'm listening, I want it to be purple. I can also add things like mix-ins. Let's say anytime I want to use a flex mix-in, I just call this so that I'm supporting different browsers and things like that. The mix-in is really handy for basically packaging up little pieces of CSS and using it throughout your app. Here's my base class. I'm going to call it demo yo Esri. Here's where I'm kind of using the variables from Sass. Here's where I'm using the mix-in above. And then I have some other styles that I just use once. Another nice thing about Sass is I can nest things. So I also want a class called demo yo Esri __ icon. I can nest it inside this class, and I just have to write this. So if later, I change this to something else, this will automatically be updated. Again, I'm using some more of the variables I just defined up here at the top. I'm also adding a modifier class. So when it's listening, the background color is just going to be purple instead of the white. Also want to add a disabled modifier. So that when the button's disabled, it looks disabled basically, opacity is less, there's no pointer cursor over it if I hover it. And so that should make the complete file. Then what I want to do is I want to actually compile Sass, make sure it's working. So if I go into the folder where my CSS is, let it compile. So now it spits out a CSS file and a map file. And the map is helpful to basically see if you have some kind of, it basically links the two files together so you can see where things are being set in the Sass while looking in your browser's console. So here's the CSS at output from compiling that. If I want to kind of see that it's working, I can kind of like write some errors. I should be able to recompile, and then it would basically tell me in there that it failed. So that's the setup we're doing for this widget. I'm going to actually turn it over to JC now, and he's going to show you guys how to set up the view and the view model for the widgets.
Cool. Thank you. So I'm going to start off where Matt left off, where we have the page and the styles ready to go. So I'll show the structure we have for our widget. For example, everything, the main widget will be, the view part of it will be hosted under app, and then we have this yo Esri folder where we will have the view model and also some support classes. So let's start writing the view model itself. So I will start off by just defining the module, and I have TypeScript running in the background. So whenever I make any changes, it'll automatically compile and when I refresh, it's always going to be fetching the latest. So this is how I define my view model itself. Right now, it's just declaring a class. It's an empty class, but it's our base. So we're going to extend Accessor, and that's pretty much it. We are importing some of those decorators we covered earlier, and then to set up our class, and then I will import the properties I want on my view model. So as you can see here, I'm getting some errors because I'm referencing some modules and decorators that are not there yet, so we need to import them. This is kind of one of the neat things with TypeScript. You immediately get notified if the TypeScript compiler is running in the background of these potential errors. So I'm going to define a set of voice commands that my view model will accept, a hot word that's used to wake it up, a timeout to automatically go to sleep whenever a command isn't given in time. I kind of extracted all the interactions with the speech recognition API to a speech recognizer class, so to kind of make it cleaner and simpler to follow through. So I have this recognizer property where this is the main interaction between the speech recognition and our view model. So it's a helper class. And we also define a state that, if you notice here, we are depending on whether the view is ready and the state of the recognizer. So whenever in our state, whenever the view is ready, we can actually just delegate to whatever the recognizer state is, which can be listening, active, or processing. Listening, processing, or listening, processing, or error, I believe. Oops. Okay. And then I define a view property of type of the types it can accept. So I still have those errors, so let's fix them by bringing in the respective imports. So I will update my decorators and import some more modules. So I'm just importing other classes that I'm using, and as well as some interfaces. And this, as I mentioned before, the speech recognizer and the utility for building voice commands. I also define a local state type, which can be disabled, active, listening, or processing, and it matches the state of the state property. It's the type of the state property, sorry. So we have no more errors. Now we can move on to methods. So I want to have a way of waking it up and making it sleep, so I have these already defined. So again, I'm delegating to this recognizer. So whenever we call the wake method, it's actually going to wake the speech recognition. Same for sleep. And for lifecycle, the only thing I want to do is whenever this view model gets destroyed, I want to destroy my recognizers to make sure that it's not running anymore in the background, and then just dereference all of our local variables. So that's our view model in a nutshell. And now we'll move on to the visual aspect. Same as before, we're going to define our view module. We are one of the differences between the previous example is we are now extending a widget instead of Accessor, because that's going to be the base class for our widget. Same thing, I'll import properties. I want to keep it really simple, so I'll just import the view model and the view. So you can set the view and the view model directly on your widget instance, and it'll the view will delegate to the view model and set the view property there. And I've also wired up the view model property to be renderable whenever the state property changes. So if the state of the view model is changing during the lifetime of the widget, it's going to trigger a render, which we'll show in a little bit. I'm going to add some of those missing imports. Okay, so no more errors. Now I'll focus on my methods. So these are the public methods. Actually, I'm missing. Okay, sorry, I missed the a few. Oh, sorry, got confused. So this is our render method, right? In a nutshell, it's just storing the state of our view model and defining some root classes, which will be applied to the root of this widgets node. And I'm defining, storing the type of the icon that I'll be using. So let me get rid of these errors to kind of make it easier to look at. I will define a lookup object for our CSS, and you'll notice that it's using the BEM classes that Matt went over in our previous example. So this makes it easier. It's a pattern to make it easier to look up CSS classes. I will also define a type for the icon that will be used by the widget. And I will also update the imports. Okay. So now this is better. So the render method itself is going to create, this is the root of our element, right? And then we are assigning a class, and if your widget will dynamically be adding or removing toggling classes, this is where you would use the classes attribute, and this object will reference a CSS class, and based on the condition of the value of it, the class will be added or removed dynamically whenever the render method gets called. And I'm also setting up the wake method to be called whenever the node is clicked or the key down event is fired. And I also want to make sure it's focusable, so I add the tab index of 0. So now let's add those missing methods. So I've extracted the logic that determines which icon to use into this helper method, and based on the type, which we defined previously, it's going to return either a microphone icon defined in SVG, so you can see the SVG is declared right in line, and same thing for the processing icon. And this is our wake method that's being referenced in the render method. Whenever it gets triggered, it's going to check what the state of the view model is, and based on that, call whether it sleeps or it wakes it up. And in terms of life cycle, I want to make sure that whenever our widget is destroyed, the view model is destroyed, and then I dereference its variable. So if everything went smoothly, this should now show a widget. Cool, yeah. So now I should be able to give it commands and respond. Listen. Listen. Zoom in. Listen. Hipster. Hipster. Hipster? That's an Easter egg, so I'll let you experiment with the demo that's on GitHub. But that's kind of in a nutshell how you would define a widget using the view and view model pattern. And with that, I'll hand it back to Matt.
Thanks, JC. So lastly, we're just going to go over some tips and tricks. So when you think about writing your widgets, also kind of think about using some of the core classes of our API, such as collections, accessors to kind of extend things, stuff like that. Also want to talk a little bit about accessibility and also locales, like setting your widget up for being used in different languages. So it's good to consider when to use Esri core collections instead of arrays. If you need to be notified when an array changes, this will help do that. Also using Accessor instead of plain objects so that you can listen to properties, things like that. Adding properties to your views to kind of manage states. So you can set them as a renderable decorator, and then the widget will redraw when it needs to. Also, hiding nodes using JSX instead of CSS is a nice thing. And then, setting private and protected variables when you need to inside your widget and view model, so you're not exposing or protecting certain things. When you're making widgets, make sure that they respond to things like tab indexes, setting ARIA roles for accessibility, and then making sure that if you have something that works on click, if it also needs to work on keyboard events such as enter key and spacebar and stuff like that. Here's an example of how you'd get your widget set up to use different languages. So you just import a file as an IE10N file from wherever your widget is. We usually have an NLS folder inside of our widgets. And then you can basically, inside that root NLS file, you can specify the default language strings, and then followed by a list of all the languages you're going to support. And then you'd have a folder inside your NLS folders, with all the languages that would have a version of that locale with the strings defined in a different language. If you guys want to learn more about Accessor, there's classes here at the Dev Summit, building classes using Accessor in the JS API, using TypeScript with ArcGIS JS API, and then tomorrow we're doing a session going a little bit deeper into widgets and how they're ported and stuff like that. It's tomorrow morning. These are just links for you guys if you want to look at the code. Here's a link that'll kind of set you back to our API where you guys can find out how to do things. So this is the source code link you guys have been waiting for, I'm sure. esriurl.com/buildwidgets2017. This will take you to the GitHub page where we have our slides, our demos, our source code files. What else? That's it? Yeah, that's it. All the good stuff. So you guys can try out that listen demo if you want to. Try the hipster command if you get a chance. Don't forget to take our survey. It helps us get better at presenting and knowing what we need to work on and fix, what we should mention and not mention, stuff like that. So you can do that on the Esri Advanced app. If you go to that, search for the session. At the bottom, there's a place where you can rate different things about us. So with that, we'll take any questions. I think we have like a minute, so. Yes?
Can you go back 2 more slides, please?
Sure, the code link? Yeah. Any other questions while we're looking at that? Yeah.
Are these widgets using virtual DOM?
Yes, they are. The question is, are the widgets using virtual DOM? Yes, they are.
Which one?
Do you want to expose that information?
I mean, it's using maquette behind the scenes. Yeah.
Yes, yeah. But it's kind of behind the scenes where that way if we need to change it later, we could. So, but yeah, it's using virtual DOM, yes. You first, and then you. Yeah.
What JSX?
Say that again?
You say it again. What JXS? What?
So in TypeScript, in case config, what JSX?
So if you go to the TypeScript setup page, we provide the TS config to kind of get started with widgets. So you can get a look at that. Does that answer your question?
Yeah, I just want to know, are you guys, is it React?
No, it's not React.
It's something that Esri.
Yeah.
Question?
Did I understand correctly that the TypeScript, that even the widget framework itself is recommended but not required?
TypeScript is required for widget development if you want to develop widgets our way.
If you want to use our view models, you don't have to. If you want to use our widgets and view models, you don't have to write TypeScript. But to develop a widget with our framework, you need to use TypeScript. Does that make sense?
I think so, but I can build widgets in local style digit models that are using the JS4 API. Is that correct? As long as I'm not using your framework?
Exactly.
Yeah.
Exactly.
Yeah, so you're not required to implement widgets this way, but I mean, you should be able to do both.
Yeah. Yeah, we're trying to be independent here and flexible so that you can use whatever you're comfortable with or whatever you want. This is just our way of doing things, and you guys can use our way, or you can use whatever framework you want.
I'm just thinking about the transition plan.
Yeah, gotcha. And also have questions. Yes, sir?
What about events between view and view model?
Well, the question is, what about events between the view and the view model?
You mean the view listening for events on the view model, or you mean?
I click some button.
Yeah.
What's going on? What's the path?
So when you click a button, it's just UI at that point. So you decide whether if the handler does something to the view model to dispatch some sort of event or handle it within the view. It depends on.
Yeah, I think you need to think about it a little bit. When you click a button, you can, call the view model to perform some method, which then could, emit some event, which your view maybe is aliasing, or it could just stay inside the view if you don't need to use the view model at all. It just depends on what kind of action it is. If it needs to go get data, or if it's strictly just a UI concern of the button.
Okay, so
Where to put this event?
so when you say event, do you mean a custom event or from the click? So when you do a click event, could you pull back that slide where we have the on click? So when you're creating inside of your render method, when you create your node, you can pass along to the onClick handler, to the onClick attribute, a method, right? That method will get called whenever the click event happens. So and then you can just do whatever, that one. So there you can see the onClick gets a handler, and then you decide what to do with it.
This handle click is on the side of view.
This is a custom one, a custom on the view.
Yeah.
Yep.
How do you debug TypeScript?
Say that again?
How do you debug TypeScript is the question.
So you mean outside of the compiler system? So one thing that you can do is create source maps. So TypeScript can automatically generate those for you. So when you're debugging, for example, web in DevTools, in Chrome DevTools, if you get an error, want to step through some code, you can place. It knows how to map the compiled JavaScript to the TypeScript, so you can debug from there. That's one option.
Yeah, it's like the same as Sass too. They both output a map file that the console will use, and you can see what code is executing. It maps TypeScript and JavaScript together.
In the sample code, I saw you kind of using a mixed way to import module from, import module require.
Yeah.
Is that just a mix, or you have to do that?
That's TypeScript.
That's the question was about the use of mixed import styles. So it depends on how you define your modules. So in the examples that we walk through, I'm importing helper functions that I exported a certain way that require it to be imported using the bracket style. But if you define, sorry? Okay. No, it depends on how you define your module or whatever you are importing. So based on that, you need to import it a specific way. So I could have authored those functions a different way, and they could have all been required.
It's because of the way the source code is written.
Yes. Yeah. But I could have authored it a different way, the source code, and have the same way of importing.
Is that a guideline for us to know what module I should use import from, what module I should use import require? I think like those views, view mods are using the import require, and those decorator related things are using import from.
Not right now. I think right now I believe every class in the API and utility can be imported using import name equals require. But I believe it's just the decorators and the decorators where we are using this format.
Okay, I can do all things using import require.
Yes.
I cannot do all things using import from.
Yes, but I believe you can't mix either. It depends on how you define your module, but in terms of the API, require should work, except for the decorators. Yeah.
And this way of building widget work for WAD widgets?
It should. The only thing that we expect from to be able to render to the page is a DOM node. So if it wraps one of our widgets, it should be able to be displayed as long as we have access to a node. Yeah. Any more questions? Yeah.
The JSX code you showed in your demo was only with a single button. What's the procedure if you have like 300 lines of HTML to inject in it? You have a separate JSX file.
No, so the way we've been doing it is, so the more complicated or complex your render method gets, we start extracting them into different functions to generate pieces of the UI, and this can be done more depending on how your render method grows.
Trying to find one that's a little more.
Oh, and all the you can look at. If you go to the reference page, all of the widgets, we share the source to the widget file, so you can actually look at the code.
Yeah, we kind of like separate them into variables or constants, I guess, and then we kind of piece them together. And basically, that'll piece together those constants. So some will have like, okay, there's a warning node if the trim search, if there's a trim search term. Otherwise, there's no warning node, and then we'll use that somewhere else down below. So it kind of separates them out, and you can have them in functions or whatever, and those could be in separate modules if you wanted to separate those out too. So you can kind of piece them together. They're modular.
Could you show the page where SDK?
SDK?
Where they can get if you look at any widget and then click on the TSX file.
Oh yeah, so if you go to our API reference and you go to widgets, so for example, any of these widgets, based on toggle, there's a link to the TypeScript file, and that'll just take you to GitHub, where you can get a copy of the view. So you can take this, tweak it, and make it a totally different view if you want to. Any other questions? Okay, thank you guys, and enjoy lunch.
Thank you.